Okay, and I'll pass it over to Chris to start.
Great. Thanks, Jen. Yeah. So thanks everybody for joining us today. We've got a lot of content to go through, so I will do my part quickly. We've got two other speakers as well. We've got Jason from Snowflake, who's actually here in the room with us, and Todd as well from our data engineering team, who's going to give you a peek at Snowflake. So the whole point of this presentation really is to, I think the perception and maybe some of the initial perceptions of Snowflake were strictly around its kind of, you know, the magic of Snowflake as a modern data warehousing platform. And I think what we're trying to do is expand the understanding of Snowflake and how it's so much more than just a data warehouse in the cloud, you know, through its ability to share data both internally and externally, the ability to build applications inside of Snowflake, and a number of others. So that's what I'm going to go through up front, just to help everybody understand and communicate back to organizations that, you know, Snowflake isn't just the next generation of a database. It's a lot more than that. So I'm just going to make sure, there we go, things are moving. So that's me. I know we can't see each other, but my role at Newcomp is to lead our analytics practice. So our data engineering and data science team here in Calgary is where our Western Canadian office is located. So that's where we're doing our presentation from today. Newcomp, I think we work with most folks who are attending. From what I can see, it's a big list, but I think most of you already know of us and who we are. But Newcomp has been around a long time, since before I was doing this, certainly. Based in Toronto, not a massive company. Newcomp's still less than 100 people, but you know, really laser focused on analytics. So you know, we stay focused on that analytics pipeline, kind of from acquiring data through to kind of storing it, to enhancing it, and then delivering it to users and allowing users to do, you know, both basic analytics and data visualization, and then very advanced analytics and machine learning and beyond. So we stay very, very focused in that. Obviously, we have very strong kind of governance practices and information management practices. In fact, this is kind of how we chop up our business, so into these 5 practices. So most of you are probably already familiar with, you know, the capabilities inside of BI and data visualization. This is a pretty widely understood part of the market. Now, we have a dedicated practice for budgeting, planning, and forecasting, which might seem a little strange, but if you think about it in terms of performance management and the cycle that has to happen to actually make a good decision, you know, you run a report or a dashboard to understand how things have happened, right? So you're looking at a rear view mirror, what happened in the business. You're doing some ad hoc analysis, or maybe drilling a little bit deeper to understand why those things happened. And then really, once you understand why they've happened, you should go back and replan and reforecast and reallocate your resources, right? And then you start the cycle over again. Well, now that I've put money into something else, how did that change the outcomes? So that's a very dedicated practice for us. Our advanced analytics practice, something I think a lot of people would also be familiar with. This is where we're building math and stats models to predict, classify, segment data in a forward-looking kind of way. I'll skip to the end and talk about our data source, our open source and data science practice. So this is now very into the world of AI. It's the subsets of AI like machine learning, and subsets of machine learning like neural networks, right? So this is the part of our business where we are kind of on the edge of technology and kind of pushing computing and models to understand the world of data around us. And then underpinning all of that is our information management practice. So this is everything around governance and the storage of data, assuring quality of the data that's in there. Obviously, with all of the data that we're dealing with today, this practice is becoming more and more important. So, so that's the way Newcomp's chopped up. Okay, enough about Newcomp. The way that we think of Snowflake, you know, I wanted to give our perspective as well. I think it's important that we share with you what we're seeing in the market, what we're seeing in our client base, how Snowflake is being deployed. And so we're trying to find a really concise way to sum up all the different ways that it's being used as a platform. These are the things that I really want everybody to think of from a cloud data warehousing perspective. Has to be enterprise grade. These things have to scale. That doesn't just mean up, that also means down. So scale works on both sides of the spectrum, right? It needs to be easy to start with and then scale to massive grade. Has to be multi-cloud. We're in a multi-cloud world now. You can't be locked into one cloud platform. We'll talk about that in a bit, but you need to be agnostic when it comes to which cloud platform you're on, and Snowflake is that. And you need to be participating in the data economy. We're going to explain what that means from an economic standpoint, but now data is such a commodity that it is moving around. There are people marking it up in between, just like a good in the market. So we'll talk about the data economy. These are the main, when we talk about Snowflake as a data platform, sure, you are going to see that Snowflake is a cloud data warehouse, right? So that is what it does very, very well. The engineering of Snowflake works in the favor of moving your data warehouse to the cloud. When we're talking about data that maybe wasn't traditionally in a data warehouse, non-relational, non-rows and columns kind of transactional data, this is where data lakes started to pop into the market. So Snowflake being able to handle semi-structured data becomes the data lake and is very well suited for that. We're going to talk about accelerating analytics. We're going to talk about building really strong pipelines and doing your data engineering inside of Snowflake. Sharing data, we've got a lot of really good examples on, once you get data into Snowflake, that's great. Now it's all in one container, but how do we expose that both internally and externally? How do we build mission critical apps that depend on Snowflake as the backbone? And then how do we drive, or at least open the door for you to kind of push into the world of advanced analytics and data science, allowing your data scientists to run very, very complex models without impacting casual and everyday users' ETL processes on the data warehouse itself. Okay, so a lot to go through. I'm going to build this out a little bit just to show you what we think of when we think of Snowflake as a platform. So this is just a way to visualize it, right? So Lambda architecture allowing for ELT and ETL to move into the Snowflake platform. We've got Snowpipe so that, and we'll explain how that works in a second, but Snowpipe is the kind of real-time ingestion engine, right? So you drop a file into your S3 bucket, automatically ingested into Snowflake, no messing around. We can also pull in semi-structured data. So think in terms of, if you buy third-party data like Stats Canada data, a lot of the APIs on the Government of Canada website come back to you in XML or JSON format. Weather data will come back in JSON format, right? Any API calls. So we need to be able to handle that as well. We need to be able to clone data. I'm going to talk about that in detail, but we don't want to create copies of data anymore. We want a way to clone data without actually creating multiple versions of the truth. If we need to have test and dev environments, we no longer need to have a separate instance for that in the Snowflake world, and I'll explain how this works. We just give it a separate little worker node, and now we have a test dev environment. Again, we don't need to copy data. We can just clone it, make it available for test and dev, and then go back to the production version of it. So, and that can be sized up or down, and we'll show you how elastically it scales in a second. Time travel, a lot of us, if you live in the data warehouse world, you've probably had to deal with, managing the change of referential data over time, like in a Kimball, type 2 slowly changing dimension. In Snowflake, you can just say select from a table as it was 5 minutes ago and compare it against how that table is now, or 2 days ago, or 90 days ago. And so that's what we call time travel inside of Snowflake. And then once we've got all these wonderful things inside of Snowflake, again, we need to get it out, right? You can monetize your data if that's something that works with your industry and your market. So being able to share data outside of your organization, for example, you might give a very separate worker node for that. Snowflake has to work with, this is a massive spread of technologies out in the market today, right? So not just the mega cloud vendors in the middle, but whether they are commoditized BI tools, whether they are the many integration tools and SQL platforms, advanced analytics. We've picked a subset here, but there's twice or 3 times as many that we could put on this slide or more, right? So Snowflake has to work with all of those and does have relationships with all of these vendors to make sure that you can connect both in and out of Snowflake. So your data is not locked into the Snowflake platform. From a customer perspective, from very large, think of Capital One being, multi-currency, very intense kind of workloads, 10 lines of business, massive, massive scale. If you go to the far right, you think of PDX, from a security perspective, they wanted to build an app. This is pharmacy data, right? Very, very secure. But again, has to be performant. That's a lot of people hitting the system at once. So 150 times performance. You can only do that with something that is purpose built for the cloud. So, and we're going to explain how that works. How does that work? Well, if you're like me and you've kind of lived in this world for a while, you've probably seen these traditional architectures on the left-hand side. So, shared disk architecture, something very Oracle or SQL Server-like, right? We're contending for resources most of the time if we're all asking for data from the same table. Then next generation was kind of this shared nothing architecture. So storage and compute coupled together and then copied, right? So into multi-clusters. So if I wanted to give my ETL a different workload than my BI workload, a different worker than my BI workload, I had to create a copy of that data, another instance of it. I could separate it, but they were still married. So now I've got a copy of data, right? So that's Redshift and BigQuery, et cetera. And Snowflake decided, well, we shouldn't really have to have those things so tightly coupled. It should expand and contract automatically. We should be able to allocate compute resources independently to each of our workloads. And those workloads are just getting more and more complex as more people have access and need access to data. And it should be backed up on a very regular basis. So we'll show you, this is how Snowflake handles it. And the next half of the presentation is really just how was this done, right? So if you think of all the panes on the left-hand side, and you've been a DBA or worked in a data warehousing team for a while, we're going to explain how the world has changed. So Snowflake as a data warehouse, I think this is probably the easiest one to explain to everybody. But when you think in terms of not having to do capacity planning, remember, we're not trying to build for the high water line. Snowflake is elastically kind of adjusting itself to the workloads that are asked of it. So think of all the time that goes into capacity planning. That ties back to licensing, with your cores and Oracle, that you would have had to do in the past. You don't have to do that anymore. From an administration perspective, because I'm not doing all those things, because I don't have to, index data myself, or manage multiple copies and backups of data myself, that whole admin half of the workload is gone. And you're able, you could, Hadoop tried to do this, but that was a very, very technical, space shuttle version of a database, right? It was ultra complicated, not SQL based, at least initially. Then, a lot of add-ons and hacks like Hive had to happen to make it SQL compliant. So we wanted to make sure that SQL, ODBC, all of these standards were still usable in the Snowflake world. From a business perspective, obviously data gets separated into silos. We want to try and bring those data sets together. When people have to go around the ETL process and data warehouse, because it is such a cumbersome process, you end up with these shadow BI groups, right, that are going around creating their own exports and data sets. They might even have their own little data marts that are not even centrally managed. So we want to make sure we have one version of the truth. And it's hard when you've got a big, massive infrastructure like that is very rigid and doesn't respond to change very well. It's hard to innovate. It's hard to allow data science and machine learning to happen. So we need to kind of unstick all the backlog of data in an organization. That's why Newcom partnered with Snowflake ultimately. It's pretty selfish, but those projects were taking way too long with traditional technology. And so we needed something to kind of give us a competitive advantage. And for us, that's been our Snowflake relationship. And that really is the problem, right? Data is getting more complex. We're getting data from everywhere in way more forms in much higher volumes. It's just getting more expensive to manage that with legacy infrastructure and architectures. That takes a lot of humans and a lot of hardware, right? And effort. So the business on the right-hand side there is held back. It's hard to get to data. It's hard to make decisions, and so the platform really did need to change. When you look at a modern platform, what it has to be is performant. So in the case of Snowflake, when you build your platform for the cloud and it's agnostic to which cloud it sits on, these are near infinite resources, right? So petabyte scale is nothing in the drop of the Azure or AWS bucket, right? That's nothing. And so, when you build your platform for those cloud architectures, you get incredible performance. It also means that we can have everybody going after it at once, right? Because it horizontally scales as well. So, you can run a big complex machine learning model and do the training and not impact your financial reports or your dashboard users, right? That all sounds very complicated from an engineering perspective, but you have to abstract all that complexity, and that's what Snowflake has done with their platform. Is it's just as a service model that you pay as you go, right? And we don't need to make it more complex than it has to be. So again, I won't repeat too much of this. I think these are more for you to go build your business case when we're done today. You can take these back. We'll share this with you. I wanted to make sure you have enough reference material to take back to your teams. But really, here's how it's built. The separation of storage and compute is the most important part here. So, being able to have a separate workload for your data sharing and transactional data separated from the storage. The storage remains in one place and is built on top of GCP or AWS or Azure, right? And then this whole services layer on top. So this is the way that modern data warehouses should be built, and Snowflake did it first. This is, I think this is important because we've probably dealt with CSVs and tables and rows and columns for so long. And I actually just presented at the CPA, so the accounting conference yesterday. And the first question back to me after my presentation was, yeah, we could really use some augmentation to our data sets. We've been making our decisions off of the same 20 columns for 10 years. And so I need to be layering in production data and weather data and survey data, and all of that doesn't come in nice fancy rows and columns, right? So that's why you need this semi-structured capability, but you shouldn't have to write any specific code for it. You should be able to just use SQL and join that to regular data, and Snowflake allows you to do that. This is just a great way to communicate that all of these workloads on the right-hand side get their own computing resources. The beauty of Snowflake is that it compresses all that storage and encrypts it at rest. And storing data like this is very cheap and cost effective. And so, when we need to do you have a data science workload, we can size that up and down as we need to for that data science workload, and it doesn't impact my ETL process that's coming in on the left-hand side, right? And that can be a big or a small workload, depending on what you need. From an analytics perspective, nothing has changed. If we have one user running reports, we might have one worker node. If 500 users hit that at month end, it can just duplicate itself and scale out horizontally. And that's how we're able to handle massive scales of users and consumers. From a cost perspective, this might be the most compelling argument if you're taking back a business case to the organization. In reality, this is how usage of a data warehouse goes, right? It varies over time. Traditionally, what you have had to do if you were capacity planning is kind of build the church for Easter Sunday, right? You'd have to be building for that high water line. And so all of that empty space in the middle, you're paying for, but not using. And so what Snowflake said is that's ridiculous. Why would you pay for maximum capacity when you're not using it? And so, if you look at the blue, this is how capacity should be scaled and paid for, right? When you're not using it, it should automatically shrink itself back down. And when you ask for more compute, it should automatically scale itself back up, right? So no over provisioning. Procurement will love that because you're not overbuying, and your SLAs are always predictable because you're not going to run out of resources, right? Another really cool function, maybe just selfishly, I really enjoy this just because this is a big headache from a data engineering perspective, but being able to make virtual copies of data, right? So not just, if you're creating a test data set, let's say, and you're changing some logic in a data set, and you would have had to have copied that table before or schema or database and do your changes and then compare it to the original one. In Snowflake, that copy is just a virtual copy. So it only tracks what has changed. And so you could compare what happened after I made my logic change versus how was the data before, right? You can even create those as backups, and all it's doing is tracking changes. So you're not double, triple, quadruple paying for storage. When you're thinking of this from a DBA perspective, in that on-premise column, you can see just traditionally how much of infrastructure and security and tuning was all your responsibility as a customer. And so, you know, when somebody chooses to work with Newcomp, I don't want my answer to be, well, you have to do all of this stuff, but here's what we're recommending. Even in the first generation of cloud data warehouses, you know, the vendor took on some stuff, like, you know, they have their own data centers and they're the ones doing failure recovery. They've obviously got locks on the doors around their data center, but everything else was still your responsibility, like partitioning and indexing data. So when Snowflake built their platform, they thought of all that. And so, you know, they take on all of that admin kind of work so that you can do the higher level, higher value stuff. Replication, so this isn't just a one zone kind of thing. The, you know, data is replicated and can be brought back a sub-minute. So, you know, in disaster recovery kind of way, cross-region replication is happening, instant recovery, you know, the robust kind of infrastructure that you would expect. Again, this is to help you build the cost model within Snowflake. So 0 admin time. I think I went through most of this, but if you're going to share a slide internally, this is probably the one you want to pick. All right, let's talk about the architecture for a second. And this is another good reference for you. But again, Snowflake adheres ETL and ELT tools and replication, but at the same time allowing streaming data. Ingesting data through something called Snowpipe. I don't know if we'll talk about that today, but ingesting something in real time, allowing these ETL workloads to run, and then serving up all of that data through to data science users in our BI and analytics, and acting as the data lake. So whether on-premise or VPC. These are the technologies that we work with. So Snowflake has to be agnostic to all of these things. And validation externally, PCI compliance, all of those things are very, very important. The way that Snowflake is built as a service, if you are in charge of trying to figure out how this works as part of your cloud tenancy and multi-tenancy, just know that Snowflake, being built on the backbone of the major cloud providers, has these secure connections inside of that environment. So secure traffic, you know, data is encrypted in transit and at rest. Otherwise, we wouldn't be able to use Snowflake with governments and public entities like we do. So, you know, all of this is very, very secure. I think what's important is that even if something hasn't been developed by Snowflake to date, this is a great history on how Snowflake has innovated over time. So even just a couple of years ago, you know, looking in 2012, right, through to look how far things came in 2015 with Python and R integration, then being able to connect into Spark to do very complex models and data transformations, and then through to Snowpipe for auto ingest being deployed on Azure. Now we're streaming data with Kafka, like open source things. So really, really quick innovation inside of the industry. From a business perspective, I think you can probably think of these things regardless of which industry you come from. Fraud, you know, we just had a call with a call center, and you know, the question back to our client was, when a customer calls in and says, I've got a problem and with the service that you're providing me, and you need to provide a recommendation or an answer to them, how long is too long, right? So if you say, give me 2 minutes to look into the case, are you going to lose that customer? They're already pretty hot, right? So how long is too long, right? Is it 2 minutes or 2 seconds? I think what we're trying to do is make sure data gets to the people who need to make decisions and calls more quickly. So a lot of use cases. Snowflake has them very well documented. From a cloud, let's talk about it from a cloud perspective. Again, being built on the cloud and in AWS and Azure, this stuff, I know we have a lot of people from both Canada and the US dialing in. So regardless of what region you are in, you're likely on AWS or Azure, and so your cloud platform of choice is very likely supported. Data lake architecture, this is where we're using Snowflake. I would say this is the first place we are generally starting with Snowflake these days. A lot of compelling reasons from an IT perspective, probably more from a business perspective, in that we're able to augment all that traditional data with maybe some non-traditional data. And data lakes have failed over time just because performance. These were very complex engineering projects, a lot of silos of data anywhere. These very quickly turned into swamps because there's no good governance, no control on who is dumping data in, et cetera. So, very tough to audit. When I've got 10 tables that have a customer ID and name in them, that's a problem. So that's why data lakes have failed over time. And really logically, those were separated inside of our data architecture. So that can't happen anymore. And it had to happen because this is how it was built, right? We had a lot of open source technologies dumping raw data into our data lake. Then we had things like Spark doing very complex transformations, storing the error files in buckets, doing data conversions. That is a lot of technology and a lot of moving pieces just to get something into a dashboard, right? And so that's not acceptable anymore. That was okay 5 or 8 years ago, but it's not okay anymore. Users expect more than that, right? Especially when it comes to more advanced analytics. We can't be working with raw files anymore. It can't be slow, and it needs to change really quickly. So from a Snowflake perspective, landed in Snowflake. It's all of that because of all the things we've talked about already. The middle piece of that architecture is very, very straightforward. And because it's all in one place, it's very easy to govern and see lineage and dependencies inside of the architecture. So being all part of one platform, the distinction between data warehouse and data lake is kind of blurred now. Those just become logical layers. And so Snowflake becomes that middle container for everything, right? Serving up data in a number of different formats, whether it's pure raw data being replicated, or it's got some conformity rules applied to it, or it's got, it's modeled perfectly for some business application as a curated data set. Snowflake is intended to be the exchange for all of that data. And so from an architecture perspective, if you think back to that design pattern, this is certainly how it should be laid out. From a data applications standpoint, if you're building apps, being so quick to develop on and deploy on, Snowflake's a good pick for your data platform if you're building applications. It's live data and can support streaming data, can support interactive reporting, which tends to be more intense, right, as we're drilling up and down and asking ad hoc questions of our data, and then being able to add more context to those reports. So Snowflake being the underpinning of that, right? I won't go through this example. This is again the pharmacy, but again, massive performance increases. And then being able to do things like machine learning, right? So it is pretty complex to do machine learning, model that data, cleanse and prep it, deploy that, whether you're using Python or Spark or Scala. Build and train models in Databricks and deploy those models. The challenge with that is that most of the work for a data scientist is in engineering. About 90% of the time in machine learning is prepping data in pandas or whatever you use and getting your data ready. And most of the data traditionally lives in a data warehouse, right? So as a data scientist, you're automatically constrained to what's in the data warehouse. So instead, what we want is to just make it more extensible, be able to connect Spark to Snowflake. Be able to automatically populate data frames inside of from Snowflake, push down some of the workloads that would have had to happen in Databricks or Spark into Snowflake, and dedicate a compute node to that, so we're not taking down operational systems or reports. As an example, and before I hand it to Jason, I think just most important that you understand these applications, and maybe when I send this out, you should take a look at this list and think maybe there's something in here that we could proof of concept or pilot as we go forward. So here's some ideas for you as we move along and we share this with the team. And with that, sorry, I think I went a couple minutes over, but I'll hand it over to Jason, and he can introduce himself quickly and go through the rest of this.
Thanks very much, Chris. Really appreciate it, and thanks for doing a great job for the Snowflake overview. For those of you I haven't met, and I think looking at the attendance, probably about more than half I have, so you might hear some repetitive stuff. And for those of you I've not talked to, welcome. And I'm here, Jason Carbonic, based here in Calgary, look after a number of accounts, primarily in Alberta here. But I'm going to walk you through the concept and the application of data sharing. It is a very deep topic, and today I don't plan to go deep at all. What I want to do is give you a concept of what it is and how it could be applied within your business, and then hopefully stimulate some thoughts around what it can do for you, not only now but moving forward. Chris went through the architecture of Snowflake. There are a number of compelling technology architecture designs within that allow for what you're going to see over the next few slides. If you think of the ability to have instantly elastic and flexible environments within the cloud, the concept of data sharing becomes very, very possible, but in a different method than what we're used to achieving. So if you think of it from an IT perspective, and why has Snowflake essentially put a number of development resources into data sharing? Corporately, we believe this is going to be far larger than the market for the data warehouse, and we actually believe customers of ours, and they already are, and future customers can materially change and augment their business by leveraging data sharing. And what is data sharing? Essentially, it's a secure, trusted, instant data pipeline. And so you've heard Chris walk through Snowflake as a data warehouse, but data sharing now creates a far broader ecosystem. So from an IT perspective, it eliminates a number of things that traditionally have happened through file transfers and FTPs and everything that organizations have gone through to try to share data both internally, but also with customers and partners and others externally. It essentially is designed to eliminate a number of the IT challenges, and you'll see in a second why. But for businesses, even far greater benefits. So you're instantly able to access fresh external data. So if you think in your organization, there's probably not an organization on the phone in which data is not required from an external source or could be valuable if ingested from an external source. So having an instant access to that is certainly, businesses are seeing a significant benefit to that. Integration of those external data sources and essentially facilitate the data economy around not only the sharing of data, but the monetization of data. So if you think of, and we've heard it, and we live in the middle of oil and gas country, but data is the new oil. It will not fuel my car just yet, but from that perspective, many organizations and many more each day are realizing there's an inherent value in the data that they have, and there's an inherent value in augmenting that data with data they don't have. And data sharing is essentially designed to make that possible. As Chris had mentioned, you're going to get all these slides. I'm going to go through a couple of them really fast, but want to touch on just a few key points. So data as a priority. There's many different surveys out there, but essentially everyone is realizing that data is a significant resource that they're underutilizing right now, but plan to in the future, and certainly through data sharing at Snowflake, we hope to help enable that. This is the problem it is essentially designed to solve. So if you think of traditional methods to data sharing, here's what it looks like, and this is why it's so difficult today. It is essentially you have someone who has data and someone who wants data. And from a traditional perspective, there's a number of processes that go into essentially extracting the data, compressing it, encrypting it, and then sending it over to the person who wants the data, right? So there's 4 separate processes that just essentially prepares the data to move. And then you send it to the customer, and they have to essentially do what you did, but in reverse. So they download it, they decrypt it, they decompress it, they load it in their schema, they then see and the error check, but it's more like how many errors did they have, and do they need to redo the whole process again? So if you think of any organization, sharing data historically has been more or less through this process. Certainly, if organizations were looking to do it securely, that is difficult. It's certainly prone to errors, and essentially those things add up to hours, days, and weeks for customers and data providers and consumers to essentially exchange data. It's outdated and it's also insecure. So Snowflake's architecture, you've seen the slide, fundamentally allows us to do something very different. And what that is no data movement. So essentially, instead of the moving, an entire process to prep the data to move the data, another process to essentially make it usable on the other end, what data sharing does is in a secure, live, and completely controlled environment allows you to share data with others. And think of it in that broad context. So when I say share data with others, that could be others in your organization, others outside of your organization. Data does not move. You have instant live access to it, so there's no concerns around data being outdated. And essentially, consumers can consume it and are ready to use it. Here's the key points that if you're taking away some salient points. The first one is just like in a Snowflake environment, all the data stays encrypted and stays within the data provider's account. So if you're a data provider, you are the source of the data, that data stays with you and it stays encrypted. So security is of paramount importance and the focus of this solution. The data is live and fresh and in near real time for immediate access. So as quickly as an organization ingests data into their Snowflake account, that data is available for the ability for others to leverage it, to share it, and to use that data. So there's no latency or delay between the sources. And building off of the security topic earlier, access rights are fully revocable and fine-grained. So the data sharer, the provider, has complete control over what they share, who they share it with, and for how long they share it, and can revoke the access at any time. So the data provider has complete control of the data. So you'll get these slides as Chris had mentioned, but essentially this is what it is practically. So you share data without moving or copying it. There's no complex deconstruction or reconstruction. It's secure, and you have full data warehouse capabilities with that data, both on the provider and the consumer perspective. And so I think that from a customer perspective, think of it like your ability to share your Snowflake account, but also for others to share theirs with you. There's a couple of use cases that we have here on the slides. I will actually, I'll skip through this, you'll get this, but we actually have data sharing, I believe it's the first one in Canada, actually live now in Calgary between a resource company and a field management provider. So we have a couple of Snowflake customers here in Calgary that are actively doing data sharing between each other. And, I think that customer actually spoke at our Data for Breakfast last or 2 weeks ago, but we're certainly happy to share how they have leveraged data sharing. There's a couple of different ways. So I'm just gonna, I have just a couple of minutes left. So I want to get to the demo. So if you think of the concept of data sharing, data doesn't move, it stays fully secure. Now, if you go to how do I get data? How do I find data? What I would say is the analogy I do use is think of the App Store, right? So if you need an app for your phone, you go to the respective OS App Store, and you essentially, after the community continues to build, and in the early days it was a great place to go. Now it's filled with a lot of apps, but essentially the concept is is going to be very similar with the Snowflake data exchange. And a couple of things. There's you'll have these slides, but what I would focus on is there's going to be a public version and a private version. And so what does that mean? That means if you think of a public exchange, that is analogy I would use is exactly like the App Store. So you're going to have data consumers, you're going to have data providers. So we have a number of people like Environics and the weather and a number of providers that are going to provide data both free, freemium, and premium priced. As a data consumer, you have the ability to go and shop on the data exchange and access that data, not unlike you would do on the App Store. So simply put, that's what I would characterize that as. You'll get these slides, but again, it's certainly it is going to be very, very user friendly. So if you think of here's kind of what the UI you can expect. For those of you that have a Snowflake account, you'll see that the menu bar on the top. So the Snowflake, you got your databases, your shares, your warehouses, your worksheets, your history, and your account. There's a new icon there called the data exchange. Click on the data exchange and boom, now you're into the public data exchange where you will be able to go and shop, if you will, browse for data sets that you might want to integrate. And we have a number that we're going to going live with out of the gate, and they'll continue to grow in multiples over the next weeks, months, and quarters. So that's the public side. So if you're a company that is looking to share data, you'll be able to list your data on the exchange and have others buy it or access it like you would in an app store. If you're a consumer of data and you're looking to buy data sets, so weather data, Environics data, a number of other data sets, you'll be able to go on to the data exchange and search for and have options around what data you can quote unquote purchase or access. It's instant, it's live, and it's secure. So that's the public. If you think of the scenarios, and you'll see these build out, and I'll build them quickly, is essentially a data provider lists their data, right? So here it is. I'm a data provider. I say, here's the data I want to share. I put it on the data exchange. Now I'm a data consumer on the right. I request that data. Essentially what happens there is you now have a direct access into using the consumer, your BI, your query tools to view and access that data from the data provider in a fairly secure manner. You're also able to reverse share that data as well. So you can enhance data and augment some of the data sets. That's for customers that are both Snowflake customers. The same capability exists for non-Snowflake customers. So you're able to have a reader account. There's actually a reader and a writer account, but you're able to share with non-Snowflake customers as well, and with the same level of access and the granularity with the data and the controls. So you can share with Snowflake customers as well as without Snowflake customers. I won't touch on this too much, but Chris had mentioned this cloud agnostic component. It's, and a number of customers that I've talked to, you probably heard me say this ad nauseum, but as nice as it is to have right now a cloud agnostic approach, I believe it's going to be vitally important 2, 3, 4, 5 years out. And the reason why is the concept of sharing and collaborating and leveraging data is only going to grow exponentially. One of the key engineering and physics challenges of sharing that data is the fact that that data lives in separate clouds and separate regions. And so we all know, or most of us know, how they are able to, our public cloud providers are able to provide 7, 8, 9, 10 nines of availability as they use these availability zones. They have a fantastic disaster recovery within those. One of the challenges that you have between regions as well as clouds is the ability to move data between those is not as seamless. And so from a cross-region data sharing, Snowflake enables that through our replication. So we take out the challenges of sharing across region, but if you extrapolate that even further, we can also do that across clouds. So not unlike the feature that we have that allows you to have a disaster recovery in a different region and on a different cloud. Example being, I have my primary cloud in AWS East, and I want my backup or my DR cloud to be Azure West. Snowflake can easily facilitate that. The same way we can also facilitate sharing data between clouds and regions. So if you don't have a cloud agnostic strategy and you try to share data or access data on a different cloud and region, there's going to be significant challenges if you don't have that abstraction from the cloud layer. So I just wanted to highlight that. There's a customer success story here on the weather source. Feel free to look it up. But from a key takeaways perspective, so again, data sharing is a topic that I can spend, and Justin, who is he spoke at the Edmonton DAMA conference about a month ago, and he's spoken with a few customers here in Calgary. He runs our data sharing. Here's some of the key takeaways. High-performing companies are looking for better ways to source external data. So how can I make better decisions internally? By leveraging external data sources. Snowflake's secure data sharing means that you can do that. The data does not move, it's always fresh, and it's immediately usable. So we've taken out the technology and the application challenges of doing exactly what companies are looking to do. But the next phase of that is, how can you monetize data, right? So a number of companies are sitting on data gold mines, if you will, and they're not able to monetize them, or they've not thought of how they can monetize them. This allows an easy way for companies to not only monetize data, but to leverage and enhance other data sets. So from a takeaways perspective, data sharing allows this to happen. And here's the private data exchange, which essentially is a mirror of the public. But think of it in the concept of you control exactly who looks at your data, who can view it. Where we see this private data exchange, and actually the private data exchange, and I'm going to go quickly to this slide. When we pre-released the public data exchange to 15 of our largest customers at our summit last June, the reaction was uniformly, that's great, but we would like to do a private version as well. So we have developed in parallel a private data exchange. So it's essentially more confined and walled garden, if you will, data exchange that companies like yourselves can leverage to have customers access it, vendors and suppliers, business partners, they can enrich it and share it back. But essentially it allows all the same capabilities, but in a private or a walled garden, if you will, environment. And so before I get to Todd, I just wanted to thank you for your attention. Data sharing can go on forever. Reach out, obviously, to Newcomp and to your local Snowflake as well. This is something that, like I'd mentioned, is live now in Calgary, but we've also got a number of customers that have it in POC, and something you'll see moving forward, and it will be a big topic at our summit in June as well. So thank you for your time, and I'll turn it over to Todd.
Hey everybody, I know we don't have a lot of time left, so I'm going to try and go as fast as I can. I'll try and have the questions open. So if you do have any questions, please just let them be seen there. Hopefully someone's not microwaving, as that seems to cut our internet out.
Yeah.
All right, so the first thing I'm going to do is just log into the Snowflake portal. Depending on what cloud you choose to go on, Azure or AWS, your URL will look something like this, some kind of custom name at the beginning, .snowflakecomputing.com. You might have a region in there depending on what cloud you're on. So the first thing we're going to go through is just kind of the user interface rather of Snowflake. So we can see here that, like Jason was mentioning, we have our different kind of categories here at the top. We can go through and look at our databases. We can click on any databases that we have. And in those databases, we can see any tables we have, any views that have been created, any schemas that we have, stages that can connect to external data, such as an Azure stage or an AWS stage, file formats for those stages if we want to bring in any external data. You can create your own or use the pre-made ones that are within Snowflake, and then sequences as well. You can do many things using the user interface. You can create a table. It's very simple. Just click of a button. I can put a name in here, and then just add a column such as a test and create finish. And now my table has been created. Same thing if I wanted to create a database, I can do it with the user interface. Again, we could just type a name in here, click create. And this one's going to be a little bit longer just because we're getting that provisioning from Snowflake. And there we go, we can see now I've created a new database. So that's all you can do within the databases ribbon up here. Everything we just did, though, we can also do using SQL commands. So if I wanted to create a table, I could do that from here. If I wanted to create a database, I could do that from here. I could drop tables, I could truncate tables, I can do everything. And we can see in this left panel here on the Worksheets tab, we've actually seen this new database I've created. And then we can also see if we expand the demo database, that there's also that new table I created. We'll go back to the shares if we have enough time, but we'll skip to the data exchange. So like Jason was mentioning, this is like an app store. You can browse through, find any data that you might be looking for. There's different categories. It's much like an app store, just like he said. I'm going to move quickly just because we do not have a lot of time and I don't want to go over. So warehouses in Snowflake, warehouses are the compute nodes. So again, same as the databases tab, you can configure any warehouses you have by simply clicking on it and not clicking on the name. And you can configure any of the settings you have. So what your maximum clusters are, what size it is, minimum clusters, what kind of scaling policy you have, what the auto suspend time is. If you do sign up for maybe a trial of Snowflake, I would recommend not doing never because you'll run out of your free credits. And then if you have auto resume on, so this is what that means is if we ever try and query something using this compute node, it'll automatically turn on without us having to turn it on ourselves. The history tab we can look at. So what the history tab is the history of all the queries that have been run against your Snowflake databases in the last 2 weeks. You can use some filters based on user, what warehouses were being used, query IDs. So each query that is run has a query ID, and you can try and narrow things down based on that. Maybe if I just want to look at users, I can see what I've done. So we can see that I created that table and that test, and it's there. And we have these query IDs, which we can actually use using the time travel functions within Snowflake. We can actually adjust maybe our databases based on these query IDs that I just created. We also have partner connects in here. So if you want to connect with any partners, you can do that there. And then we have here the download section. And if we click on that, this is where you can find any ODBC drivers, the command line interface client, and any other connectors you may need for Snowflake, just in case you're using any other software within or in conjunction rather with Snowflake. Up here, we also have our roles. So you can see your username and then which roles that I have access to. So if we go to the account admin, it'll just take a second for that to switch. So now I'm using the account admin role, and that gives me access to the account button up in the ribbon there that Jason was mentioning before. And this actually lets you see what kind of usage you have, which warehouses you're using, how much credits they've used, this being Snowflake credits and how that converts to real money. You can look up on the Snowflake documentation. You can see what your billing methods are, which users and what their roles are and what they have access to. You can create new roles, or new users rather. You can look at roles and again, create new roles here, configure certain roles, what access they have. And again, this can all be done either in the user interface or in SQL commands here in the worksheets or the command line interface as well if you download that. You can look at policies, sessions, resource monitors, and reader accounts as well. Going back to the sharing, since we're now on our account admin, we can look at any sharing that we have. So we have two inbound. So this is our account usage and our sample data, and this is both coming from Snowflake. So if we go back to our worksheets, we can actually see that we have a shared database here, and this is available to every Snowflake user. And it's just a bit of sample data that you can play around with and try and get familiar with Snowflake's interface by trying to query data, looking at the different schemas. The different schemas are just different sizes of data, so how much data is actually within each of these schemas. And then the weather schema is semi-structured JSON data. Going back to the sharing, so those are inbound. We don't have any outbound, but if we wanted to create one, we can just go here, use a name, we'll just call it test, select which database we want to share. We can share that demo, and then we can select any tables within our schema that we want to share. So I'll select that one I created again, click apply, and then you can create it. Now, since I don't have anyone to share this with, I'm not actually going to do that, but it is literally that simple if you want to share it with any other Snowflake users. It is 1 o'clock. So I will leave it at that very short, brief. Oh, I see some questions, so I'm going to try and pull them down.
That's okay. I don't know if we have time to answer them. I think what we'll do is we'll follow up individually.
Sure.
So they're good questions. You know, asking why Snowflake versus, you know, native cloud data warehouses on some of these cloud platforms. Good question. Even better answers. So, you know, we'll help you with that. But I think great job, Todd. Thanks for walking everybody through the environment, and thanks everybody. I hope what you take back is that it's really easy to get started with Snowflake. This isn't a scary platform. I think if you have a legacy data warehouse, you should certainly consider your next initiative, whatever it is that you're going to append into that legacy data warehouse or something that doesn't perform in it. You should do a proof of concept inside of Snowflake, and we'll help you with that. It's really easy to get started. You're not going to have to go to the well and ask for a bunch of money to buy hardware or anything like that. We can do it in a really, really controlled fashion. So if anything, that's what I'd encourage everybody to do. Just get started. Thanks very much, Jason, for partnering up with us. Snowflake's an awesome partner to Newcomp. And with that, we'll chat with everybody next time. Thanks, everyone.